Today, we are cracking the code on one of the most powerful tools in all of mathematics. Seriously, it's a concept that lets you measure pretty much anything you can see. We're diving into trigonometry, and we are going to demystify its most famous secret.
I bet you've heard this phrase before, right? Sohcahtoa, maybe muttered in the back of a math class. It almost sounds like some kind of secret chant or an ancient spell, doesn't it? Well, in a way, it kinda is. Because once you understand what these 9 letters really mean, you unlock this incredible ability to find any missing side or any missing angle in a right triangle. And here's the best part. It's not some super complex formula. It's a simple, elegant little memory aid that we are about to decode. Right now.
Okay, so before we can use the code, we gotta get to know the key players in this whole operation. And it all starts with the good old right triangle and its 3 very important sides. First up, we've got the hypotenuse. It's the superstar of the triangle, the longest side, and you can always find it directly across from that perfect 90-degree corner. Now, the other 2 sides, they actually change depending on our point of view, which is the angle we're looking at, often called theta. The side directly across from that angle, that's the opposite. And the side that's right next to our angle, but isn't the hypotenuse, we call that the adjacent side. Nailing these 3 down is absolutely the first step. All right, we know the sides. Now it's time. Let's finally break down the code itself. This is where all the magic really happens. And you're about to see how simple this secret code really is. SOH, that just tells us that the sine of an angle is the opposite side divided by the hypotenuse. That's it. Ca tells us the cosine is the adjacent side divided by the hypotenuse. And finally, toa means the tangent is the opposite divided by the adjacent. That's the whole secret. 3 basic functions, 3 super simple ratios.
Okay, so theory is great, but what can we actually do with this stuff? Well, let's put it into practice and see how it helps us find a missing side of a triangle.
All right, here's our mission. We've got a right triangle here, and we know one of the angles is 38 degrees. We also know the side adjacent, or next to it, is 42 units long. Our job? Find the length of the side opposite that angle, which we're just calling x. And we're going to solve this with a really easy, repeatable 3-step method. First, label the sides you know and the one you need. Second, pick the right tool for the job, sohcahtoa. And third, you just set up the equation and solve. Let's do it. Okay, let's think about this for a second. We have the adjacent side, and we want the opposite side. So looking back at our secret code, which part uses the O for opposite and the A for adjacent? Is it so, ka, or toa?
You got it. It's TOA. Tangent is the function that connects the opposite and the adjacent sides. See? The mnemonic tells you exactly which tool to grab from your toolbox.
Now we just build the equation. The tangent of our angle, which is 38 degrees, is equal to the opposite side, that's our x, divided by the adjacent side, which is 42. It's just a direct translation from that TOA rule.
To get x all by itself, we just need to do a tiny bit of algebra. We multiply both sides of the equation by 42. That leaves us with x equaling 42 times the tangent of 38 degrees. Now all we have to do is let the calculator do the heavy lifting.
And boom, there we have it. The missing side, x, is about 32.8 units long. Just like that, we used one angle and one side to figure out a completely unknown length. That's pretty powerful stuff, right? Okay, so finding a missing side? Check. But what if it's the other way around? What if you know the side lengths, but it's the angle that's the big mystery? Well, sohcahtoa has our back for that too. Let's see how. So here's our next challenge. We've got a triangle with an opposite side of 5 and an adjacent side of 4. This time, the unknown isn't a side. It's the angle itself, theta. Okay, so let's look at what we've got. We have the opposite and the adjacent sides. Well, that means we're using toa again. This tells us that the tangent of our mystery angle theta is equal to 5 divided by 4. But how do we get theta out of there? To do that, we have to kind of work backwards, and we use something called an inverse function. You've probably seen it on your calculator. It looks like tan with a little -1. Just think of it like this. It's you asking the calculator, hey, can you tell me what angle has a tangent that equals this number? It's the key to finding the angle.
So, to solve for our angle, we just rewrite the equation. Theta equals the inverse tangent of our ratio, which is 5 divided by 4. You punch that into your calculator, hit enter, and voila! The missing angle is about 51.34 degrees. We just found an angle using only 2 side lengths. How cool is that?
Now, really quick, you might hear about 3 other trig functions: cosecant, secant, and cotangent. They sound intimidating, but don't let them fool you. They are literally just the reciprocals, the flipped versions of the 3 we just learned. Cosecant is the flip of sine, secant is the flip of cosine, and cotangent is the flip of tangent. Simple as that.
So after all that, what have we really learned here? Because this is so much more than just a trick for a math test. You've basically just gained a new kind of vision.
Think about it. sohcahtoa isn't just a rule in a textbook. It's the tool that engineers use to design bridges, that astronomers use to calculate distances across space, and it's what you could use to figure out the height of a tall building just by standing back and measuring an angle. It's a way to measure the unreachable.
So the real takeaway is this: you now have a superpower. You have the secret code to find unknown heights, distances, and angles all around you. So the only real question left is, what will you measure first?